I have been making games for over 6 years, and as my projects grow more complex, I realized something. There's a tool every game needs, yet nobody seems to talk about: a dev console. Your gateway to testing, debugging, and bending your game to your will. So, what is a dev console? It's basically a built-in command line inside a game that lets developers, and sometimes players, type in instructions to instantly change things. Think of it as a debug tool, a cheat system, and a game inspector all rolled into one. Instead of digging through menus or editing code, a dev console gives you a way to spawn enemies or items, teleport around the world, give players resources or health, and instantly test how systems respond to different scenarios, with effectively infinite possibilities. It's mainly used during development to speed up iteration and testing, but many games also keep a version of it for players, modders, or speedrunners. It acts as an extremely efficient way to test or set up conditions manually without having to actually play the game to get to that point, or even more drastically, to alter the back end of the game to test a specific scenario. And this is an extremely common thing in games that can appear. Minecraft has this entire chat system which acts as a dev console. You can teleport, give XP, change game modes, all through the command line, and this is built into the actual game. Binding of Isaac is another example, yet they have it hidden in the back end of the game, so it's a bit harder to access. But once enabled, it allows you to do things like spawn in items to test combinations, or even if you're deep into a run where you have a combination of items that actually breaks the game, the dev console actually gives you the ability to remove items from your run to potentially save your run streak. In today's development update on my game Atlanta TD, an ancient Greek-themed tower defense game, I'm going to talk about my dev console. I'll give you insight into why I've got it in, how it's helping development, and if you're curious about the console or how it works, or even more general, if you want to know how to set it up in your game and start creating your own commands, please let me know in the comments, because if there is enough interest, I will work on a completely free, completely beginner-friendly tutorial that you can use in any of your games. First off, why am I doing this? Well, as development for this project has gone on, and as we approach the release of the Steam page, there's certain aspects of the game that we either need to streamline or to manually control so that we can create scenarios in the game that would be visually appealing for things like screenshots and gameplay videos. Now, it's easy enough to play the game and just record the scene, but these games often start slow. The first 5 to 10 minutes of most roguelike playthroughs is about setting up the core build. It's building into the action of what's to come. And if you're testing a specific build, or you're getting footage for a specific character, you have to very specifically remember that while you're setting up your build. You'll spend the early game getting this done, only to blank out for a minute or to purchase the upgrade at the incorrect time. And now that 10 minutes of setup was for nothing. You've wasted your time, you've wasted overall development time, and you have to start again. Well, another solution is to just change the game files. Reorder the waves so that when you start the game, you're always where you want to be, and internally switching the start amount of money that you have so you can build your character up immediately. A great solution, until you forget where that wave belongs in order, or you forget the magic number of money you should have at the start of your run. Now your game design is jeopardized. So creating a dev console allows you to create scenarios and freedom into the back end without actually altering it. You can start a run, put in a command, and now you have your scenario. And this isn't actually going to affect any of the game's design. And sure, you can argue that you have to actually type the command, but that's also the nice thing. It's flexible and you can just do it at any point during the game. You can replay scenarios that you've already played in that specific run, you can alter scenarios, and you have complete freedom for how it works. Now, I'm still in the early phases of getting this dev console in, but the skeleton of it is strong enough that I can show you how expandable it is, with an actual example that I'm also going to be putting into the game today. Let's jump into the code setup. There are 2 core classes that make up the command system. The first one is game commands. This is a mono behavior that acts as the bridge between the console and the actual game. Its job is to listen for the player's input, figure out which command is being used, and then route that command to the correct part of the game, but only if it makes sense to do so. And that's where context comes in. For example, I might want a command that gives me a key or adds essence, which is the currency during a run. Those commands make sense in a run, but they mean absolutely nothing in the overworld or the main menu. So instead of letting every command decide for itself whether it should run or not, the system handles that automatically. This architecture keeps things clean. The command doesn't need to know when it can run or why it's being called, it just knows it has a job to do. The system around it decides whether the current context allows that job to happen. So let's use the essence example. If I'm in the main menu and I try to type a command like /currency gold 100, Normally the command would try to grab the game manager, access the current run data, which doesn't exist in the main menu, then it would throw backend errors and potentially break things. I also want to point out, since I added the dev console pretty late into development, I had to build a contextual permission system around the existing architecture. This way commands only execute when they actually make sense, and the console won't try to interact with parts of the game that aren't active yet. The second core script is our console command interface. This class is our boilerplate. It's what all of our commands derive from, and all we need to do is create custom behavior for each of them. For the currency, all we would do is give it a name, add a helper string, add the context, and we also have a bool function for executing the command. Within the bool function is how we determine the outcome from the game commands class. So when the game command class executes the input, depending on which command is being read or trying to be read, it will give the appropriate output. One of the commands I want is the ability to jump to different wave numbers. This is so I can test different levels, but it's also for getting screenshots or videos within certain parts of the game. So I'll quickly run you through how I would set something like this up. The first thing I will do is create a new class based on the console command interface. I'll ensure it has all the necessary properties of the interface, but give it unique identifiers. Then I'll set up the core execute function. Again, this is when the command is actually called and how the logic will be executed. Now, since I don't know off by heart what exactly needs to be called, during this part, I'll kind of search through my code, looking specifically for where I handle the current wave index. And if a method exists for manually calling that or setting that, then I'll override it with the command. It's not uncommon as well while I create custom commands that I need to extend or modify other functions. Sometimes it's just exposing the function. Other times it's actually creating a universal way to call the function, say through the game manager. But for this example, since up until now the waves are increased incrementally, there was never a need to set a specific wave number. So I'll actually be creating a new function for this command. Then inside of the execute function, I'll actually call the set wave number, and then over in the game commands class, I'll register the command to the dictionary so that it can be called. And that's pretty much all the setup that we would need. Once we have that done, we can actually test it out. And the first thing for this that I like to test is to make sure that the context is correct. Since this is a run specific command, I'll call it from the main menu, just to make sure it doesn't actually execute. And we can see that it doesn't. We'll then go into the game and see how it works. Calling the command, we can see that it does call correctly, and it does change the wave. And obviously the next question here is, will it actually play that correct wave? And the way to test this is for me to press play, which you'll have to take my word for, it is working correctly. I also like to test to make sure that the fail-safes are working, so inputting an incorrect value, whether that's exceeding the wave count or putting in a non-integer value, will fail the argument, which it does, so that is good as well. That is my dev console. The setup is relatively straightforward, and as you can see, it's also super easy to just expand on. Thanks again for watching and sticking around. Please do interact with the YouTube buttons. As always, it helps to get my videos pushed through the algorithm, and like I said, if you want your own dev console in your game, let me know. I'll work on a tutorial that can get you started creating and testing easily in your own game. Thanks for watching, and I'll catch you in the next one.